And we'll go through Brooks, the last of Brooks, which you should have finished reading today. Check it off if you haven't already. Missing deadline up here. And we'll go through Webster 2 or 3. Whatever the set of Webster readings was.
It was Webster 2, I believe.
And like, depending on how the discussion goes, I'd like to see if I can get done by quarter till. And you use the rest of the time to run away or do team meetings, whatever you want to do. Okay, no silver bullet. As I say, possibly one of the single most important essays ever written about information technology, certainly about software engineering. Because I can tell you from personal experience, people have been looking for a silver bullet for 40 plus years. It's like, nope, this technology, it's going to do, things are going to be great. I mentioned I wrote a book called Pitfalls of Object-Oriented Development. I wrote that back after 5 years of doing full-time professional object-oriented development. And object-oriented development in the early 90s, you can do it 10 times faster, you don't need to do QA, it's all just going to be wonderful. No, seriously. Yeah, you don't have to test, it's all objects. And here's the interesting thing is that what I discovered after writing the book is that really, particularly the first several chapters of that book, the pitfalls are all applicable to pretty much any new technology or methodology. And your Webster number 7 readings are literally those pitfalls from my book, but generalized to technology or methodology instead of just objects or object technology. Because for the 20 plus years since the book came out, I've been seeing the same arguments over and over again. I posted just a listing of those pitfalls on a private listserv for people who used to work at Next Computer, and someone immediately responded and said I could say all the same things about Agile as it's practiced currently. The same mistakes are being made. Doesn't mean objects aren't good, doesn't mean Agile is good, but people keep expecting miracles. They think there are going to be silver bullets. And there aren't. The problem, what we have with software is we keep developing tools. Which end is supposed to erase? Our tools keep sort of raising the foundation. I mean, when I started, back 1974, I became CS major at BYU, coming off my mission. The introductory class was 132, not 142. Our first programming language was machine language on an IBM 360 using punch cards. And then we evolved from there to 360 assembly, and we had to buy a Fortran textbook and pass off a test on Fortran on our own. Basically, had to learn on our own. The foundation of what you can count on keeps being lifted. But what happens is it merely lifts the expectations. I've mentioned Sundog, game I did for the Apple II. I knew almost literally the entire memory map. I mean, there was only 64K of memory. And I knew what was going on everywhere. I had everything carefully blocked out. I did very careful memory management. Like I said, I wrote my own graphics library from scratch. There's graphics memory there. I could swap windows and do things like that. But that was 64K of RAM, floppy drive we used, a double punch floppy disk that you could flip over, so it was a total of 280 kilobytes of disk storage. That was the operating system, the P-code environment, the graphics library, the entire game, all the data, everything ran in that environment. Okay, that's about the size of an icon on the screen these days. My laptop has 16 gigabytes of RAM, and that's no longer cool. That's kind of like, oh, only 16 gigabytes? My son Aaron is the lab manager over for the information technology department. He has a server there that's got 1.5 terabytes of RAM in it. It's like, well, this is cool. For years, I'm going off into old fart stuff, my apologies. For years, a personal goal of mine was to have a desktop system at home that had 1 terabyte of hard disk storage in it, which I achieved about, I want to say about 12 years ago in DC. Okay, my new goal is to have a petabyte before I die. Have a desktop system that's got a petabyte of storage in it. So, what did you do? You know, well, what would you need a terabyte for? You know, what do you need a gigabyte for? Hit your phones. I like that. But the point is that however things change and build, the universe you're dealing with gets more complex. Stop and think about those. All of you are working on projects. Stop and think about all the things that you have to interact with. It's your host operating system. And for many of you, it's multiple operating systems because you have a back end and you've got a front end either on a PC, a Mac, on a mobile device. You've got libraries that are coming from various origins. Well, we're using this tool, we're using this language, we've got this, and so on. You have to know and rely upon this stuff. And all this does is it sort of raises the bar of what's minimally acceptable. I'm old enough to remember when a graphical user interface was something cool and innovative. I was literally there when the Macintosh was introduced in February of 1984 in Cupertino with Steve Jobs' presentation. And it's like, actually I already seen the Mac before then. But it was like, this is so cool. This just changed everything. And it looks absolutely archaic these days. Here are the issues, core issues. Software gets complex in a nonlinear fashion. The state space of software becomes astronomical. In fact, it becomes super astronomical very quickly. By state space, I mean the number of possible different states that you can have existing in software. You run out of trillions and quadrillions pretty quickly with large complex systems. You look at all the different variables you can have, all the different data, all the different interactions, and you need new ways of managing that complexity. You have to work with, as I said, an ever more complex environment. Everything else you're depending upon. One of my maxims is that the upper bound of quality of any system you develop is the quality of the lowest quality component you're relying upon. Now that's actually cushioned something because if you only rely on it like once every 3 days, okay, that's not a big deal. But generally speaking, your software quality is at the mercy of everything else you depend upon. Whether that's Mac OS X, Windows, Linux, whether it's a particular language compiler you're using, whether it's a particular library you're using, particular modeling engine, whatever. Changeability. There is a constant pressure to improve or fix existing systems. If any of you are looking for a book to read for extra credit, let me suggest Faxon, Fallacy of Software Engineering by Robert Glass. That was actually my required text for the last 3 semesters. I switched out for Accelerate. But it's still a great text. I just didn't want to require 4 of you. It's pretty easy read. It's numbered facts and fallacies. One of the points he makes is that basically 2/3 of the change requests on a system under maintenance are new features. Most of you are going to be working at some point on maintaining existing systems. Well, generally speaking, you're not going to come out of college and say, we want you to build a brand new app for us. It's like, here, go fix this set of features, go add this set of features and fix these bugs in this system. And that increases complexity. Yes?
What was the book called again?
Oh, Facts and Fallacies of Software Engineering. Robert Glass. If you go to the website and look at the extra credit reading page, it's listed there. Thin book, fast read. That's what I try to do with all these books. And something we've talked about almost every week, invisibility. It's hard to inspect and examine software and then determine how close it is to being done. Very much unlike a building. It's very hard to do this. And you're going to run up against this again and again. Things that do help. Well, one of the biggest things you can help is buy. Now, again, back in the day, Fred Brooks, there wasn't a lot of commercial software for anything. Companies would build their own accounting systems from scratch and maintain them. They would build their own human resources systems from scratch. One of the key things that organizations have learned over the past 20 years, 30 years, is that it is often far better to buy and adapt than to build your own. And we'll talk about this later in the course, but the general rule of thumb is you buy to be on the same playing field, and you build to win at competition. Which means if I'm a corporation, I'm not going to spend my time and resources building my own custom accounting system when I can go out and buy, Oracle Financials or whatever I want to buy. What I'm going to build is the system that allows me within my marketing space to give me a competitive edge over my customers. Requirements, refinement, and rapid prototyping. And this is, again, this was something relatively new. Fred Brooks wrote this in '89. This is what you're doing. You're doing requirements, refinement, and rapid prototyping. You expect 2 prototypes. You're going to refine your requirements. Now this is, and he's basically talking here about Agile. Show it to the customer. Let them see it. Let them give you feedback. Likewise, incremental development. John Gall wrote a great book, which is sadly out of print, called Informatics, which actually was meant to be somewhat satirical, but contains some very powerful truths, and this is possibly the most powerful truth. A large, complex system that works is inevitably found to have evolved from a small, that should be simple, not simply, a small, simple system that works. What you will see instead is you will see organization after organization trying the Big Bang approach. We're going to throw everything in there but the kitchen sink, and we're going to work and release it with all those features in it. Again, I can't tell you how many software disasters I've reviewed that have taken exactly that approach. My friend and colleague Bruce Henderson puts it more succinctly. He says, start out stupid and work up from there. It is an obvious truth. You want to take a small, simple system that works as evolve it. Again, that's very much an underpinning of Agile. So many organizations do not do that. They want to do the Big Bang. I think it was actually one of the mistakes we made at Pages. If I were doing Pages over again, I would probably argue at this point for a much simpler initial release as soon as possible. Because when we finally did release 1.0, remember my comment about, oh, we want it to work just like the old system, but better. This is a design-oriented desktop publishing system meant to have exquisite graphic design and so on. And the requests we got are, we want WordPerfect key bindings, we want Emacs key bindings, we want a ruler so we can futz with it. And we put those all in. Those were all in 1.1. It's like, okay, that's what the customer wants. Great designers. Yes?
Well, I want to ask you about that. Not to put you on the spot, but how would you have narrowed the scope? Because this type of system seems like you kind of need it all. So if you had a name like a bare bones first deliverable on Pages.
I would have had fewer elements, fewer design elements and graphic elements. I would have made it more something like a design-oriented notepad. You can call it up, you can bring up a page, you can do relatively short memos and letters, but they look nice. I would have done that for starters. I would have postponed footnotes because that was a pain point. Let me tell you, that was a pain point. There are a number of features like that I would have said, okay, we're just going to pass on that for right now.
Follow-up question on that. What about a time box for that deliverable? If I mean, knowing what you know now, it's not fair, but what would you have pushed for as a release date with a smaller feature set?
I think I would have pushed, once we closed on funding and got some people involved, I probably would have pushed for 12 to 18 months. And say, so let's see what we can get out 12 to 18 months, and get some feedback, and use that to sort of lay the groundwork for what we're doing beyond that. And it actually would have allowed us to swing greater, because 18 months in, we would have realized that Next was not going to have the installed base that we thought it was going to have. Elegant design, elegant architecture, elegant design increases the flexibility of what you're doing. You get higher performance, you get more flexibility, you can adapt it to new uses and applications. What do you see, since so many of you have actually been out there working as interns and real jobs and so on, what have you seen in terms of managers, fellow workers, etc., wanting or believing there is some kind of silver bullet to software development? Any first-hand experiences? Thinking, well, if we just do this, it'll just all work. Not yet? Okay. Yes?
Not specifically where I work, but I've heard that a lot with immutability and functional programming. People seem to think it's a silver bullet.
Oh, yeah. Yeah, but it's always the latest technology. It's, oh, yeah, just functional programming. You know, we're going to do this, we just do this, and it all just works. Yes?
One company that I worked at, I feel like the management had a really good grasp on things where they worked very carefully with the programmers and listened to all the feedback that they had to give about everything, and they were reluctant to switch to new technologies when a huge project was already underway.
That was very smart on their part. Yes?
At my work, I've seen that when there is something that appears to be a silver bullet and we pursue that, when we learn that it's not, making the solution we want is just a quick fix away. And so we make a quick fix, and then we realize, oh, we need to make this other fix too. And soon we build this pile of hacks on top of this silver bullet, and it's just a mess by the end.
That is exactly what happens. It's like, oh, you know, anyway, yes.
Do you think that happens more often when the manager is coming from a managing background instead of a technical background?
Yes, I do, because usually the manager hasn't had the painful experiences to teach her or him otherwise. One of the pitfalls that I mentioned back with object technology, and this was so true, was technology choices by Business Magazine article. There's an article, you have a CIO who subscribes to some CIO magazine, and you get an article talking about the great wonders of, say, functional programming. You know, this is a great thing, and so the CIO says, we're going to do functional programming, and we're going to do it on this mission-critical project that's got a tight tent on it. Which is exactly what you don't want to do, but it's what they do. Or we're going to switch to functional programming in this project that we're a year into because we think we'll get it done sooner. That happens all the time. It really does. And it causes real problems. The analogy I like to use, and actual history notwithstanding, it's like taking a boxer and entering him into a karate tournament. Say, we'll give you a week's worth of training in karate, and we're going to have you compete on a professional level. You know, and he may be able to defend himself some, but chances are he's going to get thrashed because he doesn't have the depth of knowledge and training and instinct to know what comes naturally. He doesn't know what mistakes not to make. And that's the problem with anything new, whether it's a new technology or new methodology, you don't know what mistakes not to make. You're going to do your wandering through the wilderness that Armour talks about. Other comments? Yes?
I was going to say, one thing I think that solved that problem kind of well was I was working in a company. What they do with 99% of their interns is the managers will take a project where they think there will be a silver bullet or something. Instead of taking with full-time employees and having them do that, a lot of the time they'll take their interns and have them kind of investigate it. Because they're only there for a short period of time and say, okay, if it doesn't work by the 3 months that the intern has been doing it, then we're not doing it, instead of wasting the valuable resources of the full-time.
Yep, and that's the approach. You want to do pilot projects with any new technology, technology, methodology, whatever. Do pilot projects that are not on the critical path. And you don't want to take people, there's sort of the only thing I might add to what the company does is you may want to reward some of your best developers by saying, hey, we're going to give you a group of interns for 3 months of summer. And you're going to go investigate the software with them, because this particular language or particular thing. Tell us what you think. And at the end of that, the interns go back to school. The senior developer then says, hey, this is really cool, and I see how we could apply this. And then you start off with a low priority project. You don't put it on a critical project. I've mentioned before, in reviewing failed projects as an expert witness, a pattern I have seen consistently is, up to deadline, slip 6 months. Up to deadline, slip 6 months, and suddenly they adopt Agile. Right after the second slip. Almost always with no one with actual Agile experience. But it's a silver bullet. It's like, we're going to do Agile, we're going to do sprints, and we're going to figure out the features. Like, you're already a year late. You've never used Agile. And what happens almost inevitably is they do it for, it's a little scary how predictable it is. Second slip, they adopt Agile, they use it for 2 months, they abandon it. I have seen that in multiple projects. And it is a classic case of trying to adopt a silver bullet. Now, Brooks, yes?
Would you say that in those situations it's better not to try anything new?
Yeah. Part of the issue is there was great software being developed with, the C programming language and structured development. It's remarkable how much the world runs on COBOL. Language which fortunately I've never had to program in. My experience with COBOL was as an undergraduate, I picked up a language book on COBOL one day, spent a weekend reading it, was convinced I could teach myself COBOL if I never had to learn it. Unfortunately, never had to. But there are billions and billions of lines of production COBOL code out there. You'd be surprised how much the world runs on COBOL.
What languages are,
Huh?
what languages use COBOL?
No, COBOL is a language.
Well, right, but I'm wondering if it's like C++, like Python is a language, but Python is basically built on C++.
No, COBOL was actually pretty much its own thing. It's a very verbose language. Part of the original intent of COBOL was that managers could code in it. It was sort of like the original 4th generation language. Very English-like, a very verbose syntax. It really didn't derive off of anything else. You basically had, in the era when we're talking about late 50s, early 60s, you had Fortran that was scientific and math programming, and COBOL that was business programming. You had PL1, which was sort of the universal language, which at one point, in the early days of PL1, if it had a compiler error, syntax error, it would simply guess what you wanted and correct it and keep compiling. Yeah, that was a feature everyone kept turning off very quickly. It's like, no, don't you decide for me what I want. PL1 was actually my first high-level language. Even before Fortran. Anyway, so chapter 17. This is Brooks in 1995, basically saying, yeah, all these things aren't going to happen. Talks about rad Cox with component software. We're software factories. We're simply going to build software out of these building blocks, Lego blocks of software, which is a terribly appealing idea. But there's a fundamental problem with reuse, and I was in the middle of the whole reuse thing when I was at Fannie Mae, running 24 consultants there. Fannie Mae had a big reuse initiative. We want to reuse software. And it's tied to the use of object technology. We want reusable objects that people writing different applications can use. Now, Fannie Mae, it was set up by the US government basically to encourage home ownership. They do this by buying mortgages from banks. So the banks now no longer have to manage the mortgage, and banks get the cash so they can loan that cash out as well. Fannie Mae then manages the mortgage, and it creates what are called mortgage-backed securities, which it sells on Wall Street, and that gives it money to buy more mortgages. So it's sort of this middleware broker for mortgages. So the fundamental object class that Fannie Mae was interested in was the loan. And they thought, because it's a mortgage, basically, not a loan, I mean mortgage. They thought, okay, we'll have a universal loan object, and everyone will use that, and therefore it will all be interchangeable. And I was the mentor to the reuse project. And after about a year, they had this object class that had about 200 methods and about 700 fields in it. And no one could use it. And one of the lessons learned is that even though you may have an object class, or whatever you want to call it, that is ostensibly representing the same thing, the actual usable abstraction for any given application may vary widely. And reuse was a big thing back in the 90s, and it sort of died. You know, it was the single most reusable thing they found? Shell scripts. Shell scripts were highly reusable. Object classes, not so much. You have a question?
Would you say that Brooks would classify that type of objective as a lower right quadrant kind of objective, where it's something that you're building that other programmers are supposed to use? Or
Yeah, actually, yes. That's his most complex quadrant. It's system software to be as a product to be used by others. In this case, the object class was going to be used internally, but still, it was this big bloated object. So there's a big reuse project that failed. He talks about David Harrell with vanilla framework, which frankly I've never heard of. I lived through that whole era. Object-oriented development was seen as a silver bullet. Trust me, it was not. I actually fully agree with Brooks. I've been watching this for 40 years, and there are no silver bullets. Now, we get improvements. There are great things. Frankly, we'll talk, the third book you'll read is Accelerate. It talks a lot about DevOps, CI/CD, things like that, which I believe improve quality, generally speaking. So those of us who use Facebook know what it's like to suddenly have Facebook start acting completely differently. It's like someone just checked in a change. I hope they back it out soon, because this is annoying the crud out of me. So there are things we can do to improve productivity within organizations, but you don't have order of magnitude improvements from a given technology or methodology. Any other thoughts or observations here? Everyone's like, no, I'm getting into class. Chapter 18, great cheat sheet for the open book midterm. Okay? If you're on a midterm and you say, Brooks said that somewhere, turn to chapter 18 and go down the list. It's, oh, there's where he said it, and go to the chapter. So very useful.
Question about that.
Yeah.
Can we cite that chapter? Or
No, don't cite that. I want you to cite the actual chapter. Where it actually says stuff. Okay, chapter 19. Someone mentioned to me about how dated one of the chapters they were reading seemed. And yeah, a lot of what the technology Brooks talks about is dated. You'll see something of the same thing in Peopleware, though it's been through 3 editions, but even there, some of the references are dated. But you know what? The principles and issues and problems, they're still ever good as applicable. I've been watching all this for 40 years. I still have one more lecture. I see some of you starting to really complex. He sees conceptual integrity and the need for a chief architect as being his most important argument. I agree. Now, it talks about define your set of users, who they are, what they need, what they think they need, what they want. It says it's far better to be explicit and wrong than vague. Why? Yes?
I feel like it's easy to refute something when it's explicit and like well defined, and when it's vague, because then everybody's like, oh yeah, but they all have different ideas.
Exactly. If it's vague, your team members will all have their own little pictures of what that feature or requirement means, and it won't be until you get down into the implement. Oh no, I thought it meant this. Well, I thought they was supposed to do this. No, I'm doing it this way. So as you push along, I don't expect explicit detailed requirements this week. I expect you a first draft just describing what you want to show in November or December. But as you go along, you want to make things more explicit. Push it out. WIMP, Windows icon mouse pointer. Graphic user interface, which is something novel for Brooks. Now he thinks voice will replace it. I don't. It's very hard to position to pick something on a screen strictly by voice. There's too much ambiguity, and frankly, it's too hard to sit and describe it. I can just go and point to it. Bill, one to throw away, he says, iterative development. Someone from Herndon, Virginia calling me. Go away. Go away. How many of you refuse to answer your phone if there isn't caller ID on it? Yeah. It's kind of sad how things have changed. Hi. Oh, it's a phone call. I know who this is. Oh, caller ID. I'm old enough to remember when caller ID first came out. And it was so great. And now it's worthless because most of the calls you get on your cell phone don't have caller ID. It's like, who is that? Some telemarketer. He talks about Barry Bohm, who's done tremendous work in software scheduling and estimation. And hardly any projects succeed in less than 3/4 of the calculated optimal schedule, regardless of the number of people applying. It's hard to speed up a project with more people. There is, Brooks will say, yeah, there are cases in which it actually does help to have more people on there. And you're back to the, does everyone know what I mean when I say high cohesion, low coupling? You want your systems with minimal interfaces between them, and that's a loose coupling. You want tight cohesion within them. Brooks was wrong on information hiding. He says that. I fully agree with him. I wasn't wrong with information hiding. I think it's cool. But this gets back to your organization matching your architecture. And there was another thing I was putting here. Oh, anyway. Sometimes, I know what it was. Sometimes if you have something that's sufficiently loosely coupled, you can add more people to that. And it won't impact communications among the rest of it. And you can get things done there. For the most part, as he says, as a zero order estimate, yeah, you don't want to add people to a late project, yeah.
How can waterfall be iterative?
Well, actually, most waterfall diagrams you see dating all the way back to the origin of waterfall will look like this, and what they'll show is arrows going both ways in each step. So if you have, just an example, analysis, requirements, implementation, test, basically says you do analysis, you do requirements, you go back and do some more analysis. From requirements you go to implementation, and that can push you back to requirements, and that can push you back to analysis. Iterative thing simply sort of says, well, we can go all the way back here. So, and again, keep in mind, for all that we tend to sort of, oh, waterfall bad, I would say 80% of the software the world runs on is developed in a waterfall fashion. But most waterfall is not, we do all the analysis, then we do the requirements. I mean, DoD tried to do this, and that's why DoD has so many software disasters. So the analysis has to be all done, signed off, we're never going to go back and revisit it. That just doesn't work. People are everything. You will hear that. Studies show the quality of the people you have is the single most important success factor into a project. Actually, these first two items, and power, giving up power, that's what we're going to talk about with our next book, Peopleware, Part 1, Chapters 1 through 6. Read the whole book. His biggest surprises were the number of computers. Again, if you go back to when Brooks wrote Mythical Man-Month, 1975, the numbers of computers in the world probably numbered in thousands. Now, if you throw in mobile devices, there's several billion computers in the world. They have become ubiquitous. You have this, again, as mentioned, this massive move towards shrink-wrap software and now apps. Now he talks about 4G languages. We've touched on a little. This is sort of language for the common people. This effort has been tried repeatedly over the last 40 years, and it almost always falls down. For the reasons we've talked about, the software produced by a 4G type language like HyperCard or PowerBuilder or whatever can't be any better than what the language actually is capable of producing. And it's almost guaranteed to be worse. Yes?
I'm just not familiar. What do you mean by shrink-wrap software?
Oh, software you pay for. Again, back in '75, most software was custom built. The idea of shrink-wrap software was a novel invention in 1975 when the first personal computers came out. You started having shrink-wrap software. And most of it, even for personal computers, was quite expensive at the time. Okay, next assignments for next class. We are going to get some extra ones. I'll go through them quickly. Post your initial requirements document draft. Submit your team status report. Watch